Hello everybody, welcome to another video lesson. Today we're going over one of your favorite topics, and that is graphing. We're going to continue on with our reciprocal functions with graphing. We're going to determine some properties of reciprocal functions as well as identify their transformations. So let's hop right into what the graph of a reciprocal function is. And what is a reciprocal function? It has to do with our rational functions and expressions that we've been looking at, as it is a function in the form of f of x is equal to 1 over a to the x, okay, where a to the x is some linear function itself. All right. Now, our reciprocal functions do have horizontal and vertical asymptotes, so be careful with those, and we'll see how we can identify those. And the shape that we get right here, you guys may know, is called a hyperbola. Okay, a hyperbola is what this shape is. Now, what you see here is the graph of f of x is equal to 1 over x, okay? And when we talk about transformations, we often talk about the parent function, which is just the simplest function for a family of functions. So a reciprocal function, or reciprocals, would be a family of functions here. And 1 over x is going to be our parent function for our reciprocals, all right? Now, whenever we have this parent function, we also talk about the transformations. So in this case, we have the transformation form here, that we have a over b times x minus h plus k. Okay, and then h and k are exactly what we've seen previously, are horizontal translations, vertical translations. So horizontal translations shifting left to right, and vertical shifting up or down. A shows us our orientation and shape, and B is a bit of a new one, but again, that's going to affect our orientation and shape in a little bit of a different way. Okay, so let's go ahead and hop into Desmos and see what we're talking about here. Okay, so we are looking in Desmos here at our generic function with transformations, okay, and we've got sliders for A, B, H, and K. So if I take the slider for A and we get larger and larger, we can see that we have this, what we refer to as a vertical stretch here. So a vertical stretch when A gets further from 1, all right? And then if we go in between 1 and 0, we do what's called, or we result in a vertical compression, okay? So A is going to be vertical stretch and compression. And we've seen this before. If a goes into the negative values and it is less than 0, okay, then we have a reflection about, and it's kind of hard to tell which one it is, but this is going to be a reflection about the x-axis, okay? So this curve here is going to go ahead and flip down under my x-axis, and then the curve that I had below the x-axis will flip and be above the x-axis. So that's what A is doing. And again, as I get further from -1, it is going to vertically stretch again, okay? So the absolute value of A gives me my stretch or compression, and the sign of A that is less than or greater than 0 tells me if I have an x-axis reflection or not, okay? So that's A. Let's take a look at B. Now B, it looks like it's doing something very similar here, okay? Now the difference between A and B is that B, notice since B is right next to X, okay, we want to think of that. X runs horizontally, right? That's our horizontal axis. So B is going to stretch or compress horizontally, okay? So it's a little bit different with what's going on with A. It can look the same with our, on our graph here, but actually it is stretching and compressing in the horizontal direction, not the vertical, okay? And now, since this is the horizontal kind of effect that we have, it is going to give us a reflection about the y-axis now when B becomes negative, okay? So now we have a reflection about the y-axis. So as I flip here and B becomes negative, the curve that was in the first quadrant moves to the second quadrant. The curve that was in the third quadrant moves to the fourth quadrant when we reflect about the y-axis like that, okay? So I'll move B to B1 again, and we can take a look at H, which we've seen before. So we have x minus H here in our generic transformation form. As H shifts to 10, again, we're just going to shift H units to the right. And as H becomes negative, then we're shifting h units to the left. All right, so that's h. And then, as you might assume with k, that is going to shift up or down. So as k becomes negative, we're shifting down. And if k is positive, we are shifting up k units. All right? Okay, so again, with our reciprocal function transformations, this is what we have going on with each value. This is what we should write down for our notes as far as what's happening with each of these individual values that we will see here in our transformation form. Now, one note that we need to add as well is that we have two asymptotes. We have horizontal and vertical asymptotes for all of our reciprocal functions, right? And those asymptotes are going to shift and intersect at hk, okay, the coordinates hk. So that can always be a great starting point for you when you're graphing a reciprocal function with transformations, because that hk is always going to be where your asymptotes will intersect. All right, let's go ahead and get into some examples here. First example, we're going to determine the domain of our function. Now we know our domain, the restrictions here are going to be when our denominator is equal to 0. So what we need to do is just set the denominator not equal to 0, and we can go ahead and solve for whatever that value is. So I'm going to set x minus 1 not equal to 0. I'll add 1 to each side, and I'll get x is not equal to 0. So our domain is going to be x is not equal to 0. Now when you write your domain like this, this assumes that your domain is true for all other values except for this one restriction, okay, which in this case that is the truth. So x is not equal to 1 lets me know that all other x values work except for 1 itself, okay? So go ahead and see if you can't find the domain for the function here on the right. Pause the video and quickly find that out. Okay, our domain here, we should have x is not equal to negative 2/3. All right, let's move on and identify asymptotes, domain, and range of each of these functions. Okay, so again, my h and my k are the first things that I should note here. So h here is going to be 3, and my k will be negative 2. And I should know that my vertical asymptote is always going to be x equals h. Okay, x equals h, that's always going to be my vertical asymptote, which in this case is going to be x equals 3. And then we can say my horizontal asymptote is going to be f of x equals k, so whatever my k value is. So in this case, f of x is equal to negative 2. That is going to be my horizontal asymptote. Now we can immediately get our domain and range from our vertical and horizontal asymptotes for these reciprocal functions. So our domain is going to be x is not equal to 3. So whatever the vertical asymptote is, just put a not equal sign in there, and that's my domain. And for my range, f of x is not equal to negative 2. So again, whatever my horizontal asymptote is, just put a not equal sign in there, and that is my range. Now, if I were to go ahead and sketch this out, the first thing I should do is go ahead and draw in my horizontal and vertical asymptotes. So here at 3 and negative 2. And again, that intersection point is going to be hk. And we can go ahead and just, if we were asked to sketch, then all we would need to do is sketch our curves in from here, knowing the orientation, knowing A and B themselves, okay, and the sign of A and B. All right, taking a look at our example here on the right, if I have hk, in this example it is going to be negative 1, 5. So again, vertical asymptote would be x equals negative 1, getting that from h. Horizontal asymptote, f of x is equal to 5, getting that from k. And from there, we can tell our domain and range right off the bat. And we can go ahead and graph that as well. Again, starting off with my horizontal and vertical asymptotes and then working the curve from there. All right, let's go ahead and graph our reciprocal function transformations now. We're going to graph this instead of just sketching it like we did on previous slides. So to do this, I'm going to first start off by factoring this denominator. I'm going to factor out a negative 3. Okay, if I factor out a negative 3 here, now I get 1 over negative 3x minus 1, all minus 2. Okay. Now, typically, I know when you guys look at fractions, you would say, oh, well, this shouldn't be, this negative should either be out front or up here. In this case, for our reciprocal functions, we're going to leave this in the denominator because we factored out this negative 3 from the denominator. Okay, so let's leave that here because that's going to affect our b value. Okay, but my h and k now, my h, you might have thought, I don't know, was like 3, And in fact, that is going to be, you might have thought was -3. That's actually going to be 1 here, because this is our proper transformation form. Okay, so then my k would be -2. And again, we can get our vertical asymptotes right from h and k as x equals 1. Horizontal asymptote, f of x equals -2. And again, from here, we can immediately put in our domain and range. Okay, so x is not equal to 1. F of x is not equal to -2. So that part's pretty easy. And then we can go ahead and start graphing, or start a table, and we can start picking some points here. We want to pick points on either side of our vertical asymptote. So if my vertical asymptote is x equals 1, then my x value should be 0, -1, -2. I'm just working, all these ones I'm working to the left side of x. And then 2, 3, and 4, I'm just working to the right side of 1, of x equals 1. All right? So we can go ahead and plug in our values for x here, and you'll find some values for f of x. And then we can go ahead and graph from there. Again, start off with your horizontal and vertical asymptotes. Right here, this intersection point is going to be hk at 1, -2, like we see here. And these black dots are the points that we picked here for 0, -1, and 2, and 2, 3, and 4. Now you can see here we have sort of a shallow curve here when we graph these points. So if you were to graph these 3 points and you don't get much from them, you may need to graph a couple additional points, like say x is equal to 0.5 and 1.5, and you might get a better idea of how sharp or wide your curve is going to be as it approaches your asymptotes. All right? Okay, last example, we're going to write some equations from some real-world situations. Okay, so we've got our upcoming spring dance. The total cost for the facilities and catering is going to be $45 per person. And then we have this deposit of $2,500. Okay, so we want to write and graph an equation, just one equation, to represent the average cost per person. All right. So anytime you guys see this $40 or some amount per person or per mile or whatever that is, okay, that is going to be a variable that we use. So I'll have my 40 in there, 40. And then this per person will be my x. Okay, so x is going to be the number of people that are attending the dance. Okay, and then we'll have our function c of x. C of x is going to be the cost per person. So let's see, I've got $45 per person, so that's 45x. We're trying to find out the cost here. So if I add this deposit to that 45x, and I'm going to divide that by x, that's the number of people that are coming to the dance. Okay, so the more people that come, the less per person we're going to have to pay, because we will sort of divide this $2,500 deposit by the number of people who are coming. Okay, so let's think about our domain here. Our domain is going to be x is greater than 0, because I mean someone's got to be at the dance, right? Someone's got to go. We can't have negative people at our dance, so we're going to have x is greater than 0. And for our range, our cost, c of x, is going to be greater than 45, because no matter how many people we have at our dance here, it's not going to go lower than $45, because I have this added cost of splitting up my deposit here of $2,500. Okay? So if we go ahead and graph that function, you're going to get something that looks like this. Okay, again, we want to be working in quadrant 1, okay, because it's kind of where our real world is happening right here. And if I were to zoom in right here, you can see that we are approaching a horizontal asymptote of 45, but we're never going to go below that asymptote. All right, that is all the examples that I have for today. Good luck with your practice.